All right, I love Garmin products, but they do have some downsides. One is the inability to parse one set of data and determine whether you were walking or running during different periods of time, and then give you data about those periods of time and not the other periods of time. So what I mean is I want to know during all the portions of an interval run where I'm running, I want to know stats about the running specifically, and all the portions where I'm walking, I want to know about those portions of walking individually, not treat it as one big set of data, but actually parse out the running and parse out the walking, and then do analysis based on those parts individually. Currently, the web tools don't do that. Maybe there's a web tool out there that does, but I have not found it. So here's how I'm going to use a spreadsheet to accomplish that. All right, so when you use a Garmin watch, you get a .fit file. All right, so your .fit file basically comes with a whole bunch of timestamps as one column. This is when you export it as a CSV. You get your time, you get your pace, you get your distance, you get your heart rate, and then you get a whole bunch of other stuff. So how it's formatted is you have one column for time, and each of those timestamps, it reports each of these data values. Okay, so at this time you've ran this far, at this time you've ran this far, at this time you're going this speed, at this time your heart rate is this heart rate. All right, so when you plot that data, it starts to look like this. So if you do an interval run, so what I have been doing recently is, so you do a walk to warm up, then you run, and then you walk, and then you run, and then you walk, and then you run, and then you do a walk to cool down. All right, so there's all these regions where the human eye can obviously tell that obviously you're running during the higher pace portions and you're walking during the lower pace portions, right? So how do we parse that data out? In addition to pace, it also reports distance. So if you make an addition to this distance along the x-axis, this is 0, let's say 10 meters in, it reports it as meters. 10 meters in, you're at 10 meters, then you're at 20, then you're at 40, then you're at 60, then you're at 80, and then you're at 100, right? So what I want to get out of all this is I want to get the distance that I've actually ran. So, this obviously is 20 minus 10 equals 10. All right, so this is 10. 60 minus 40 equals 20. So this is 20, and so on and so forth. 100 minus 80 is 20. All right. Unfortunately, the auto filter tools within LibreCalc or Excel don't really do this automatically. So we are going to have to inform the software of where those edges are. So you have a start, a stop, a start, a stop, a start, a stop. How do we determine what's a start and what's a stop? All right, so we want to be able to cut this data like this, and then say everything above this line, this is running. All right, and everything below this line, this is walking. And then so we can get this period of time, distance, pace, heart rate, that's for walking. This distance is for running. This distance is for walking, this distance is for running, so on and so forth. All right, so the question then becomes, what value is this line? How do we determine the value of that line? All right, so your first guess might be a median. So to those who don't know, a median is when you take all of the data in a data set and you organize it from the smallest to the largest. And if you do that with an interval like this, you're going to have a data set that looks like this. You're going to have a slow ramp up for your walking because you're never going to be walking at the same pace. And then you're going to have a huge step change where it changes to running, and then a slow ramp up for your running because you're never going to be running at the same pace either. And then you pick the center value. This is the median value, is 50% of the way through that data is you get the median. All right. Here's the problem with the median If you're walking to warm up and you're walking to cool down, and these are even intervals, there will always be more walking. There will always be more walking, right? So there's always going to be this delta between the median value and where your running actually starts. That will always exist. This is largely your warm up and your cool down because that's the delta. If these are even intervals, then the excess walking comes at the start and at the end. So there's always going to be this delta right here. So median isn't going to work, right? Because what you want is this value. You want this edge value so that we can determine where it starts and where it stops. All right. So that brings us to... All right, now let's show you how to actually do this. So when you finish your activity in Garmin with the hardware, you press save, and then that uploads it to your device, which then uploads it to their servers through the Garmin Connect app. So now you have to open up connect.garmin.com. So that's not the app on your phone, that is the web console. So you could probably do this on your phone in a web browser, but I just use a computer. All right, so then you open up your activity, and then you click in the top right corner on this gear icon, and then you go to export file. Don't click on any of these other things, just click on export file, okay? So I'm gonna click on it, and that gives me a zip file. Then you open up a new tab and navigate over to fitfileviewer.com. Fitfileviewer.com is a great .fit file viewer. It can also parse it, and you can download CSVs from it. There's probably other tools that do this, but I like fitfileviewer.com, so that's why I use it. So if you see, you go to record, there's 766 rows. That's how you know that it's the one you want, because there's 766 data points for this particular workout. All the other ones have like 1 row, 2 row, 1 row. That's different data. It's a lot less rich data. Record is the one you want. That's going to give you the data that we can actually use. So click this download as a CSV. I always click localized format just so I know what time these things are happening. It doesn't matter though. You can click either one. The spreadsheet will still work. Then you submit that. Now you have a CSV file. Open that. And then you want to select everything in there. Control C. And then you move over to the fit file parser, which is this guy. So you want to navigate over to G1. G1 is where the data starts, the data input starts. So I control V, and now I have my data, okay? Don't worry about that, we'll talk about that later. So now my data is in here, okay? So now let's go back to the distance tab. This is your reporting tab. So this is kind of a good practice when you're using Excel or using wherever, is you want to have kind of like a nice tab that shows you all your data, and then you want to have kind of a messier tab that has all your data and your calculations and stuff like this. So this is actually kind of showing your insights, the output of all of this work that you've done. Okay, so here we can see what we were talking about on the whiteboard. So here's your data, there's your walking, here's your intervals with your running, high pace, low pace, high pace, low pace, high pace, low pace, and then here's your cool down walk. And you can see it's actually quite noisy data. There's a lot of different paces in there. And so that is part of the problem that we are trying to solve here. Here is the other graph on the whiteboard, which is the median graph. Okay, so here's the sloped data. That's all the walking that took place. And then here's that step change that I was talking about. And here's the slope for the running. Okay, so here's all the running, here's all the walking, and we want to cut it right in the middle so that we can get that really clean edge. This yellow line is the median. This is the median of this data set. So whatever data set you'll put in here, it'll show you the median. I've done the math on the other tab. This median, as you can see, it's not sufficient. It's cutting into the walking because there's always more walking. So, you know, if you're a little savvy, you can tell from the definition of a median, which is 50% through the data series, that this line is going to intersect this line at exactly halfway, right? And so there's that delta that I was talking about. There's that extra walking. So how do we solve that? Okay, so we use percentiles. So that brings us to this graph. So our goal here is to put a number in this cell, A4, alpha 4, that's going to put this yellow line right in the middle of all of this data, okay? Right in the middle. And in fact, you can see this little spike here. So really we want to kind of put it here. We want that to be right there. So right now the percentile is 0.64. So what that means is that this line is at the line dividing the bottom 64% from the top 36%. That's what that yellow line is representing right now. So if we change that percentile to 0.63, you can see the line moves down a little bit, just a little tiny bit. You probably couldn't even see it. So maybe I'll go down to 0.60 so you can have more of a dramatic, there we go. And actually that's pretty much, 0.60 looks like the right value for this data, okay? Because we're cutting right across all of it. We're capturing all the running and we're ignoring this noise here. Now, let's say you put in the wrong value for a percentile. Let's put in like the 40th percentile. All right, so you see that that's not good. That's not what we want, right? So if you put in the 50th percentile, obviously that's your median. Median is 50th percentile, if you haven't picked that up already. So you can see that that cuts the data at a really bad spot. We're getting all sorts of noise in there. We're getting all sorts of walking. So I think 0.6 is really the one that you want. So that's kind of the first thing you're going to do when you get into this spreadsheet is you're going to set your percentile value so that you are visually confirming that this is the right line. There's mathematical ways of doing this to get the spreadsheet to automatically do this for you. I haven't done that because that requires a bunch of work that I don't think is necessary. And I think that we can just kind of use the human visual cortex to do what it does best, which is pattern recognition. So we see that this yellow line is cutting our data where we want it to be cut. All right. Now, all you have to do, because LibreCalc does not have auto updating pivot tables, you need to go to cell A1 or wherever to select this pivot table and refresh it. And that's actually giving you the proper values. You go back to distance, and this is the distance that was ran. 2,405.68 meters. That is the distance that was run during this interval, right? And then that's parsing it out from, here's your distance. If we go to the bottom of the data, the total distance covered was 5,193.63 meters, right? So that's the solution. That's what this spreadsheet is giving you, is it's taking out of that about 5K workout, you're pulling out the distance of it that you actually ran. And that's what's relevant to the kind of things that I track, is I want to know how far I ran. All right, so you can end the video now if that's all you want. Just download the spreadsheet and follow those steps, and that'll give you what you want. Now, for the people that want to know a little bit more about how I accomplish this and a little bit more about LibreCalc in general, we move on to the data tab. So here's our start and stop edges. This is a little farther along, and then here is the math. So this is the stop edge, here's the start edge. 803.77 minus 475.05 equals 328.72. Okay, so for that interval, that's how far I ran. That's how far I ran. That's how far I ran. That's how far I ran, so on and so forth. Okay, so that was the math that we were talking about earlier. How do we get there? All right, so I'll take you through each column. This is basically the calculations are happening right here. So here's your nth percentile minimum value. And what we mean by nth percentile is the value that you're putting in here. So right now, n is 0.6 or 60th percentile. And that's giving you a value of 2.6554. Here's one thing that actually might make this a little clearer is we'll select the enhanced speed, click format, go to conditional and put a color scale on it. We want 2 entries. We put in green. Actually, no, we want red for the minimum and we want green for the maximum. And this is going to give you a visual representation of where you ran and where you walked, right? So green is running and red is walking. So that kind of helps you to understand the math that's being done here. All right, so the nth percentile value is 2.6554. So what that means in terms of the calculation is once this enhanced speed value goes over 2.6554, then we consider it running, okay? Now we start tracking distance values, right? And then we go back to nil because it goes down. This was a walking portion. Goes above, now we start tracking distance values. Goes below, this is a walking portion, we get nil. Then above, we get distance values, okay? So on and so forth until you have distance values for all of your running intervals. All right, so now basically you need to create a truth table. So nil above, nil below, and number. So what this means is this cell, is there a nil above this cell, right? So basically the condition for being a start cell or the start edge of a running interval is that this is a number and the cell above it is nil. That's how you know that you're starting a run interval. This is a stop cell. The definition of a stop cell is a number with a nil after, right? That's the end of your running interval. So that's a stop cell. So we'll start with the start cells. So nil above, and then these ones and zeros, that's true or false, right? So obviously this nil has a nil above it, so those are all ones. But then you get into the numbers, this one has a nil above it, but this one does not, so you get a 0, all right? So that's your logical edge. That's your logical edge. That's what's going to form your truth table. Moving on to the stop cells, same deal, except the other way around. So is there a nil below this cell? So you can see all the nils, they have ones, ones, ones. This does not have a nil below, but this is a number that has a nil below. So that's your 1, right? That's your 1. So that's your logical edge. And then the second condition is it a number? So is this a number? Yes. Is this a number? No. So 0, 1, true, false, right? So this now is your truth table. 1, 0, 1 is the code for a start cell, and 0, 1, 1 is the code for a stop cell. All right, so that's how we use the logic. We just have 3 columns that are analyzing this column, and then we're giving a logical output, and that logical output is then assessed with this cell. So if, and, blah, blah, blah. Basically, you can look into the syntax if you want, but basically it's just analyzing these cells. If these cells line up, then we want that distance value. If these cells 0, 1, 1, code for a stop cell, then we get that distance value. So start edges and stop edges. That's what we're looking for, right? So this is a start edge and that's a stop edge. That's what we were talking about on the whiteboard. And this is how we're mathematically achieving that. All right, so now we want to combine them. So start and stop edges, very simple, because wherever there's a start edge, there isn't going to be a stop edge. Wherever there's a stop edge, there isn't going to be a start edge. So we can just do a simple sum. So we just add them together, and now we have the start and stop edges in a column. All right. So now we have a column full of zeros with interspersed start and stop edges. This is where the pivot table comes in. We go up to the pivot table. You insert a pivot table. When you insert a pivot table, you get, this is how you input data into a pivot table. For the row fields, you want to put in start and stop edges. That's the final column in these logical and mathematical columns. Really critical though, this is the whole reason for the pivot table, is you open options and you click ignore empty rows. Ignore empty rows. That's the only point of having this pivot table, is that we are ignoring the empty rows. That gets rid of all the zeros, and then you're left with clean data. Start, stop, start, stop, start, stop. These are all of your edges. That's all you want to do. So now we're left with the original equation that we were talking about on the whiteboard, which is the distance that you've reached here minus the distance that you've reached here equals the distance between these two edges. And that's what we want to total up to get our distance ran. Very simple. You know that all of these start and stop edges are going to be ordered so that it's start, stop, start, stop, start, stop. You know that it's going to be ordered that way, so you don't need to do any extra math. The data comes with that order pre-installed basically. So all we do is if error 0, so this just suppresses all of the values that we don't want. A4 minus A3, so that's this distance minus this distance, equals 328.72 meters. Okay, 328.72 meters is the distance that was run in this run interval. Okay, and then you just continue on, continue on, continue on, continue on, and that's giving you all of your data. Now this is interesting. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Very interesting that we're not getting actually all of the data here. Very interesting. So there's a break in the data. You can see there's a little kind of chink in the armor. Let's investigate that. 1, 2, 3, 4, 5, 6. All right. So this is what's happening here. This is what's happening, is we're getting a start and stop edge in this region. So there's a nil. So it's identifying properly that that's a stop edge and this is a start edge. Okay, that's fine. All that's happening is that we're getting one interval and then another interval, and it's skipping a distance value that is negligible, also because it wasn't even reporting during that period. The hardware isn't perfect, so you're going to get blank spots like this, but this algorithm that we've created accounts for that. So now it's that you're still recording all of your distance. You're just getting 2 intervals where there actually was one real interval, right? So you can see here, these are all 344, 351, 60 plus 283 is roughly 343, which puts it in the same order as the other ones. So you can see that there's a little bit of a self-correction function there. So then that leaves you with all of your interval distances, and then it's a very simple sum. You're just summing all of these values. And that's it. That's your distance ran, 2,405 meters, 0.68 meters. And that's how you parse this data. Thank you.